the least prefix sum. In this problem we have given an array A and we have to perform some operation in several times. In one operation we have to choose some index I and we have to multiply with -1 to ai. For example, if a1 is positive, then in one operation we change a1 positive to negative. If negative, then we have to change in positive. So, and we have given a favorite number m, and we have to prefix sum till m, that is sum from 1 to index from 1 to m is smallest from the other any prefix sum. For example, here we have given the sum from a1 to k is any arbitrary value from 1 to n, that is the sum from 1 to k is always greater than or equal to the sum from the 1 to m. That means the prefix sum till m is always smaller or less than or equal to the other prefix sum. So the here answer is always exist in given in this problem. We can say and in the for input we have given the test case, and in each test case we have given the two number n and m. Then n is number of size of the array and m is the favorite number, and then we take the input array, and then in output we have to print the how much operation we have to require. So in this problem here the given the test case. In the test case we have in the size of array is 4 and the favorite number, that is m, is equal to 3, and the array is given -1 -2 -3 and -4, and we have to check the how much number required to prefix sum till index m, that is sum from this -1 -2 -3, that is -6 is always smaller than other prefix sum. Here -6 plus -4, that is -10, which is not which is greater smaller than -6. That's why we have to change here -4. So if change -4 to 4, then the prefix sum from 1 to from 1 index to 3 is always smaller than other. Let's see the how to solve this problem. Okay, here the test case. Here we are taking the input and the test case, and the here in this problem basically idea is in this problem. For example, if we have a1, a2, a3, a4, a5 and a6, the idea behind is that, for example, prefix sum till a3 is any value x, and then for example prefix sum till a3 is some 0, then if any number which is behind this is negative, for example here a4 is -1, then sum from a3 to a4 is -1, which is smaller than a3. So here we try to make from index m. Here for example here m is equal to 3, then sum from here a3 to a6 is always the smaller than a3, prefix sum from till a3. So we try to make every number we try to make here, that is to prefix sum. Let's assume that prefix sum till a3 is 0, and then we try to make and the prefix sum from index 4 to index 6 is greater than 0, then a3 is always smaller than other prefix sum. So and for index 3 to index 6, and from index 3 to index 1 we try to, for example, here we are making the in the prefix sum from a1 to a3 is minimum. So for example, we try to make here a3, we try to sum from a3 to a1. If any time whenever we sum is sum less than 0, then we try to make, for example, if from sum from a3 to a1 is any time the greater than 0, then we have to change in try to make in the less than 0. For example, we have here we are taking an and m, and then we declare the size of the array, and then we initially the number of operation is 0, and then we taking the input of the array, and then let's the prefix sum till index m is 0. So we are declare the one practical, and here we iterate from index m to n minus 1, and whenever we basically we push the value ith value in the priority queue, which is stored in the in increasing order, and then whenever the sum is less than 0, so we for the right part here we are solving the right part from the index m minus 1. So whenever sum is less than 0, that means the sum is less than our sum is less than the prefix sum from till the index m minus 1. That means here the prefix sum till m is greater than the greater become greater if sum is small less than 0. That's why we change the one value and we try to make the sum is greater than 0. That's why we take the one negative value, smallest negative value, and try to and we have to change, we are adding the value bi. That's why we are removing that number and adding the negative one in the sum, and the increase the number of operation and also remove that number. In this way we solve the right part of that, and then we are solving now left part from index m minus 1. Here we try to change whenever the sum is greater than 0, then we try to change in sum less than 0. That means the negative and the sum prefix sum till m is always less than 0. That's why we are iterating from index 1 in m minus 1 to till 1, and whenever if any value which is greater than 0, then we are pushed in the priority which is stored in decreasing order, and also add that value in the sum, and whenever sum is greater than 0, then we remove that value, and here we adding 1 times. That's why we are removing and we adding negative 1. So here we multiply minus 2 with the number, and then remove that number and also increase the operation. So here we add total number of operation required from left side to right side, and then we have to print that number of operation. You can see here you can see the for first test case the number of operation required 1, and for second test case number of operation required operation is 1, and the second test case which is third case we have required operation 0. Similarly fourth test case number of required operation is 0, and then fifth test case number of required operation is 3. For here we have given m is equal to 2, then we change -5 and -20 and -2 -3. Then we get the smallest prefix sum from index 0 from here index 0 to 1, and similarly in the last case number of operation required 4. If we are submitting this solution, you can see the answer is accepted here. So we are submitting this solution and here accepted.